Hello everybody, welcome back. So welcome to TS SPDCL-AE revision series and question paper analysis or some important question analysis, right? So here we are discussing the topic switchgear and protection along with economic load dispatch, which is a part of power systems, right? So now see here students, welcome to AS Online and welcome to AS Engineering Academy. So through AS Online and AS Engineering Academy platform, so we are providing the free course for TS SPDCL and TSPSC Polytechnic courses here, right students? Now, this is the overall syllabus of power system. Every time I am showing the same thing: generation of electrical energy, transmission and distribution of electrical energy, power system analysis and switchgear and protection along with the economic load dispatch and utilization of electrical energy. This is the overall syllabus. So here today we are discussing about the switchgear and protection, right? And this is the overall weightage, right? So we know already the weightage of the power system. So it is 21, 18, 22, 29, 22, 16 and 16. So every time we are saying the same thing only, right? Now this is the overall syllabus students. Good evening Anita. So power system, switchgear and protection and economic operation you can see. So this is the overall syllabus here. Introduction to power system protection, electromagnetic relays and distance protection, differential protection, circuit breakers and protective schemes switches you can see, and load frequency control and economic load dispatch. So this is the overall syllabus of the switchgear protection and economic load dispatch students, right? So after knowing the syllabus we have to know the textbooks. So these are the preferable textbooks I am saying here. So Stevenson and Geiger and Electric Power Systems by John Wheely Publications and Duncan Glover, Power System Analysis and Design, and Aizen Agrath and DP Kotari students, and CL Wadhwa and JB Gupta for more question practice, right? For local state government exams, right students? Now what you have to practice? So we need to practice previous engineering services objective questions and previous PSC questions and previous gate 1 mark questions, previous state board questions and SSC JE and RRB JE questions. So this is the question set we have to maintain. Clear students? So I am saying every time, so please collect all the questions, so keep it with you, so keep practice more number of questions, right? So after getting more practice, so you will be reaching somewhat close to the target students, right? So first of all we'll see the first question of today's class. So what is the torque produced in induction relay shaded pole structure is maximum when two fluxes are displayed by, see here. So 90 degrees and the disk rotation will be from unshaded pole to shaded pole, and 90 degrees and the disk rotation will be from shaded pole to the unshaded pole, and 45 degrees and the disk rotation will be from unshaded pole to the shaded pole, and 45 degrees and the disk rotation will be from shaded pole to the unshaded pole, right students? So can anybody give the answer here? Anita? Good evening Anita. Right, yeah, good evening. Good evening Amala. Good evening Rajesh. Yeah, aspirant, very good. Durga Prasad Chari. Yes, very good. Option A, very fast responses. Bhushan, yes. Unshaded to shaded, very good. Right? Upendar, Bhanu, Rajesh, Aravind Reddy, Preeti, right? So everybody is giving perfect answers now. Right. Ashwini, very good. Right students, very good. So the perfect answer, the disk rotation you have to maintain the angle of 90 degrees and the disk rotation will be from unshaded pole to the shaded pole, and we know the shaded pole, the flux in the shaded pole structure will be lagging the unshaded pole, right? The flux in the unshaded pole, clear, right? So that we can say, so the angle difference between those two fluxes will be 90 degrees and the disk rotation will be from unshaded pole to the shaded pole we are having, right students? So most of the students has given the perfect answer, right? Very good. Yes. Next question. This is the next question. In distance protection the relay measures what? So zero sequence impedance of the line from relay up to the fault point, and the negative sequence impedance of the line from the relay up to the fault point, positive sequence impedance of the line from the relay up to the fault point, self impedance of the line from relay up to the fault point. Right. So what is the answer for this question? Very good, Amala. Triyambak, Aravind Reddy, very good. Any answer for this question? In distance protection, the relay measures what? Durga Prasad Sir given it is option C. Very good. Very fast response. Very good. KK, very good. Option C. You are saying that it is positive sequence impedance of the line from relay up to the fault point. Very good. Yes, right. So we have to set in case of distance relays, we have to set the impedance of the relay. So the preset value of the impedance, should be, very good Aravind, Ashwini Miryala, right. So the preset value of the impedance should be the positive sequence impedance of the system, right. So it measures the positive sequence impedance and it compares with the positive sequence impedance of the system, right. So that it is the positive sequence impedance of the line from the relay up to the fault point. Very good. So please go through this one. Very good, Aravind Reddy, you are giving positive answers. Right. So shall we go for the next question? Just see the next question here. For protection of parallel feeders fed from one end, the relays required are. For protection of parallel feeders from one end, the relays required are. So directional relays at both ends, non-directional relays at both ends, directional relays at the source and non-directional relays at the load end, non-directional relays at the source end and directional relays at the load end. Very good, Amala. So what are the, for protection of parallel feeders, one of the most important questions, students. So for protection of parallel feeders, so we need the directional relays at which location, non-directional relays at which location. Right. Option D. CF. Bhushan, what is the meaning of CF? What is the difference between fourth option? Yeah. Aravind Reddy, please check that. So directional relays at source point here, non-directional relays at the load end. That's what they have given. Yes, very good. Just check here. So whenever you are having the parallel feeders, just check here, students. Suppose if you are having the load point here, if you are having the load at this location. Tell me, students, where we need the directional relays. Suppose if it is 1, relay 1, relay 2, relay 3 and relay 4. 1, 2, 3 and 4. In this 1, 2 and 3, 4, so which are the directional relays? 1, 2, 3, 4. In this 1, 2, 3, 4, which are directional relays? Option D correct only, but for this one. For this question, which are directional or which are non-directional relays? So what you told is, so these two, 1 and 3 should be non-directional and 2 and 4 should be directional. Right? Here 1, 3 are non-directional and 2, 4 are directional. Yes, 1 and 3 are non-directional and 2, 4 are, yes, directional relays. Right? So at the source side we need non-directional relays. At the load side we need the directional relays. Is it clear, right? Very good. Based on the same point, I will ask you one more question, students. Based on the same topic, whatever I have discussed here. So based on this one, so I will ask you one more question. Try to give the answer for that question. Try to give the answer for this question. The distribution system shown in the figure below is to be protected by overcurrent protection. For proper fault discrimination, directional overcurrent relays will be required at locations. So where we require directional overcurrent relays. Yeah, that's what I want to discuss here. Ashwini Mriyal. Tell me students, for proper fault discrimination, fault where we need the directional relays. Is it 1, 4 or 2, 3, 5 or it is 2 and 3, 1, 4 and 5. 1, 4 and 5. Option D it is 2, aspirant given it is 2, 3 and 5. So based on the discussion, right? Yeah. Option D, option B. Bhushan given it is option B. Option D. Just check here students. Just check here. See here, whenever you are having a generator here, suppose we are having two parallel feeders like this. And you are having a relay 1 here, relay 2 here, relay 3 here and relay 4 here. We are having the 4 relays here. Now suppose students, if you are having the load here, tell me students, whenever the fault occurs in line 1, the current, suppose the current in line 1, if it is flowing in this direction, this is the direction of current flowing in line 1, and the direction of current flowing in the line 2 will be in this direction, right? Suppose if this is the minimum fault point or minimum voltage point, the fault current will move without going to the load. It is reaching the load point or fault point. Now just check here. In relay 1, if this is relay 1, this is relay 2, this is relay 3 and relay 4. In relay 4, what is the fault current direction? In relay 1, in this direction. In relay 2, in the opposite direction. In relay 3, it will be in this direction. In relay 4, in this direction. So 1, 3, 4 are having the current direction like this. 2 is having the opposite direction. Now, suppose if the fault is in the second wire, suppose if you are having the same connection, this is relay 1, this is relay 2, this is relay 3 and this is relay 4. 1, 2, 3 and 4. Now we are having the fault here. Now the fault current in line 1, it is flowing in this direction. It is line 2. In line 2 it is flowing in this direction. In line 1 it is flowing in this direction. So they are meeting at the fault point. Now check me. In relay 1, what is the direction of fault current? Same, no change. In relay 2, what is the direction of fault current? Now it is reversed. What about relay 3? It is also reversed. And in relay 4, what is the current direction? Same current direction. Now check here. So where current reversal is taking place? In relay 2, current reversal is taking place. In relay 4, current reversal is taking place. There we need the directional unit. But whereas in relay 1 and relay 4, wherever the fault is, in line 1 or line 2, wherever it is the fault, there is no change in the direction of currents. In relays 1 and 3 and in relays 1 and 3, no change. So it is 1 and 3, sorry, it is 3. It should be 3. It should be 4. It is 4. We have changed the numbering. Just check it. It is 4 and it is 3. So that it should be 4. And it should be 3. See here in 1 and 3, so we are maintaining the same direction. In 2 and 4, so here, so it is flowing in the left, so right to left, here it is reversed. And here also, so from left to right, here it is right to left. So in 2 and 4, the current reversal has been taking place. So that 2 and 4 should be directional units. Is it clear, right? Please check it. In 2 and 4, it is taking the current reversal. Now based on the current reversal theory, you have to give the answer for here. Please check it, students. Whenever fault occurs in this point, whenever fault occurs in this part. The current will flow from generator to this direction, from this generator to this direction. This direction. Clear, right? So that initially in relay 2, it is moving in this direction. Initially, in the first case, in relay 2. In relay 3, it is also moving in this direction. Clear, right? And what about relay 5? What about relay 5? Whenever the fault occurs at this location, whenever the fault occurs at this location, the current may be moving in this direction. Maybe, right? So from source to this point, so that the current is in relay 5, it will be in the same direction. Suppose in relay 5, the current will be in this direction, or otherwise no current. So why? Because the current is flowing to the fault point. If it is the current, if there is a current, that will flow in this direction, otherwise there is no current in the relay 5. Clear, right? Suppose if you change the fault point, suppose if you are having the fault here. Tell me, what is the direction of current here? This is the direction of current. So that in relay 2, it is flowing in this direction. In relay 2, the current reversal is taking place. In relay 3, the current reversal is taking place. Right? Tell me, the current is flowing like this, or otherwise the current is flowing like this, so that there is no change in the relay 5 current direction. There is no change in the relay 5 current direction. Why? Because from load, current will not come back. From load, current will not come back. Clear, everybody? If you check here, so for two different faults at two different locations, where you are getting the current reversal? You are getting the current reversal only 2 and 3. Only 2 and 3. It is not 2, 3 and 5. Current reversal is taking place only at 2 and 3. It is not in 5. So that only 2 and 3 should be the directional units. The direction is right. Yes, Arvind Reddy. That's what I am saying. Is it clear, everybody? Is it clear, everybody? Please check it. Yes. Respond, everybody. Is it clear? Someone asked the question. Aishwarya, is it clear for you? Aishwarya, is it clear for you? Right. Very good, Uma. Durga Prasad, please check it. So you have given 235. 235. If you have synchronous mission, then the current reversal takes place. Whenever current reversal takes place, then you have to consider that as the directional unit. Yes, aspirant, that's perfect. Yes, definitely. Whenever you are having a synchronous mission, so it may provide. Yes, very good. Right. So I'm going for the next question, students. I'm going for the next question. Right. Under voltage relays are mostly used for. So what is the purpose we are using the under voltage relays? Why we are using the under voltage relays? So under voltage is the problem of source or load. Under voltage is the problem of source or load. Low voltages are the problems of which equipments? Where you can get the low voltages. Right? Where you are going to get the low voltages? Is it source problem or the load problem? The low voltage. We are giving bus bar. Arvind Reddy, very good. Durga Prasad, right? So low voltages are the problems of the loads. Clear, right? Aspirant, it is very good. Right? So that under voltage relays are required for protecting the motors. Right? Very good. Yes, perfect. So low voltages are the problems of the motors. Right? So can I go for the next question? I'm going for the next question, students. Very good. Everybody is giving the perfect answers. Right. To protect against overloadings. Yes. Right. A reactance relay is a. What is a reactance relay? What is a reactance relay, students? So see here, just we can write here. So we are having impedance relay. First one is impedance relay. And next one is reactance relay, and the next one is Moore relay or admittance relay. What is an impedance relay? Impedance relay. So what is the universal torque equation, students? The universal relay torque equation. So T is equivalent to some constant K1 into, right, T is equivalent to some constant K1 into I square plus K2 into V square K2 into V square plus K3 into Vi cos of theta minus tau minus K4, where K4 is the restraining torque. So first of all, we have to get the impedance relay characteristics. To get the impedance relay characteristics, right? So we have to make K3 0. We have to make K3 and K4 0, and K2 should be negative, so that we can get V by I ratio. So to get V by I ratio, so we are using the impedance characteristics, that will be voltage restrained over current relay, What is that? Impedance relay. So for which, what is the purpose of using impedance relays? So impedance relays are used for protection of medium lines. Right. The purpose of using the impedance relays. Next one. Reactance relay. Why you are using reactance relays? To get the reactance characteristics, we have to make K2 and K4 0. And we have to arrange cos of theta minus tau such that we need to get the reactance characteristics. What is the reactance characteristics? Z sin theta. So we have to make this term as sin theta, right? So we have to get Z sin theta as the option. So whenever you are getting Z sin theta, that is the reactance characteristics. So that means to avoid the dependence of this impedance relay on the arc resistance, so that we are constructing a relay which is independent of the arc resistance or complete resistance of the system. So that we are constructing a reactance relay which never depends upon the resistance of the system, so that it does not have any impact because of arc resistance. So to give perfect solution whenever there are arcing faults like LG fault and LLG faults, the best suited relay will be the reactance relay. So that in case of reactance relay, so what you have to do, I told you, we have to make K2 0 and K4 0, we have to make K3 as negative, so that the negative portion will give the restraining part. So in case of impedance relay, so we are making K2 negative, so that it is voltage restrained. So in case of reactance relay, K3 is negative, this unit belongs to the directional unit, therefore, so this is directional restrained over current relay. So what is the purpose of this one? Protection of short lines, short transmission lines, right? And this relay is used for protection of lines whenever there are arcing faults like LG and LLG. And Moore relay. In case of Moore relay, so we are making K1 0 and K4 0, and the restraining will be provided by K2, that is voltage unit, and the relay is operating torque will be provided by the directional unit. So that it is a voltage restrained directional relay. It is a voltage restrained directional relay. So what is the purpose of this one? The purpose of this one is protection of long lines, long transmission lines. Clear, right? And whenever you are having power swings, right? So under that condition also, the best suited relay will be the Moore relay, for very high voltages. Right, students? So these are the relays we are having, right? Yes. Very good. It is a directional restrained over current relay. So that reactance relay is a directional restrained overcurrent relay. So directional restrained overcurrent relay. So option B is the perfect answer. So try to remember the names like that. Try to remember the names like that. So which terms you are making 0 for which relay? For impedance relay students, for impedance relay, we have to make K30 and K40. K2 should be negative. K2 should be negative. Which is negative? That is providing the restraining part. That is providing the restraining part. Right? So in case of impedance relay, let me write those. Here K3 and K4 are 0 and K2 should be negative. As K2 is negative, the restraining part is provided by the voltage. That's why it is voltage restrained. Operating torque will be positive 1, that is over current relay. So that voltage restrained over current relay. And in case of reactance relay, we are making K2 0 and K4 0. K2 and K4 are 0 and we are making K3 negative. We are making K3 negative. Right. Is it right? So here K3 should be negative. అంతే కదమ్మా K3 నెగిటివ్ చేస్తే సో K2 K4 0 K3 అనేది నెగిటివ్ అవుతుంది. సో K3 నెగిటివ్ అవడం వల్ల మనకి ఏమొస్తుందమ్మా సో ఇట్ ఈస్ రిస్ట్రైనింగ్ పార్ట్. రిస్ట్రైనింగ్ పార్ట్ ఎవరు ఇస్తున్నారు ఇక్కడ డైరెక్షనల్ యూనిట్ ఇస్తుంది అండ్ ఆపరేటింగ్ పార్ట్ ఎవరు ఇస్తారు కరెంట్ ఇస్తారు. అందువల్ల ఇది డైరెక్షనల్ రిస్ట్రైన్డ్ ఓవర్ కరెంట్ రిలే అవుతుంది. అంతేనా? ఇన్ కేస్ ఆఫ్ మో రిలే వీఆర్ మేకింగ్ K1ని K4ని 0 చేస్తాం. K1ని K4ని 0 చేస్తాం అండ్ K2ని నెగిటివ్ చేస్తాం. ఎందుకు ఎలా చేస్తామంటే అలా చేయడం వల్ల మనకి ఇక్కడ ఇంపిడెన్స్ క్యారెక్టరిస్టిక్స్ వస్తాయి, ఇక్కడ రియాక్టెన్స్ క్యారెక్టరిస్టిక్స్ వస్తాయి, ఇక్కడ మో క్యారెక్టరిస్టిక్స్ వస్తాయి. సో ఈ టర్మ్స్ అలా అరేంజ్ చేయడం వల్ల మనకి ఇంపిడెన్స్ క్యారెక్టరిస్టిక్స్, రియాక్టెన్స్ క్యారెక్టరిస్టిక్స్ అండ్ అడ్మిటెన్స్ క్యారెక్టరిస్టిక్స్ రావడానికి అలా చేస్తాం అనమాట. అండ్ అందువల్ల ఆ రియాక్టెన్స్ ఆ రిలేలు ఏమేమో ఇప్పుడు సో నెగిటివ్ పోర్షన్ ఎవరు ప్రొవైడ్ చేస్తారు? వోల్టేజ్. ఆపరేషన్ ఎవరు ప్రొవైడ్ చేస్తారు? K3 అనేది ఆపరేషన్. అందువల్ల ఇది వోల్టేజ్ రిస్ట్రైన్డ్ డైరెక్షనల్ రిలే అవుతుంది. అర్థమవుతుందా? సో మీరు అలా గుర్తుపెట్టుకుంటే చాలా సింపుల్ అవుతుంది. అర్థమవుతుందా? రైట్ వెరీ గుడ్. బి అంటే సేమ్ ఇచ్చామా? ఇది వోల్టేజ్ చూడండి నాన్న, ఓవర్ వోల్టేజ్ రిలే, డైరెక్షనల్ రిస్ట్రైన్డ్ ఓవర్ వోల్టేజ్ రిలే. వైఫ్ నైఫ్ ప్లీజ్ చెక్ ఒకసారి చెక్ చేయండి అమ్మా. బి అండి over current over voltage, right? So I'm going for the next question now, right students. In an IDMT relay, electromagnetic over current relay, the minimum time is achieved because of what? The minimum time is achieved because of what? In case of IDMT relay, the minimum time is because of electromagnetic damping or proper mechanical design or appropriate time delay element, saturation of the magnetic circuit. Entama answer? Minimum time in definite IDMT relay. In IDMT relay చెప్పాలి, ఆన్సర్ చెప్పాలి. What is the answer for this question? Option D, KK given. Very good. Aspirant given it is electromagnetic damping. So please check your answers. చూడాలమ్మా క్వశ్చన్ ఒకసారి. వెరీ గుడ్. అరవింద్ కోర్ సాచురేషన్. ఎస్ దుర్గా ప్రసాద్ కోర్ సాచురేషన్, రైట్. సో అశ్విని మిరియాల గివెన్ ఇట్ ఈస్ ఆప్షన్ ఏ, అనిత గివెన్ ఇట్ ఈస్ ఆప్షన్ ఏ. చూడండి అమ్మా, ఐడిఎంటీ క్యారెక్టరిస్టిక్స్ అంటే ఇన్వర్స్ క్యారెక్టరిస్టిక్స్ ఉండాలి, నెక్స్ట్ డెఫినెట్ టైం క్యారెక్టరిస్టిక్స్ రెండు ఉండాలి. అర్థమవుతుందా? ఐడిఎంటీ క్యారెక్టరిస్టిక్స్ అంటే ఏమో, సో ఐడిఎంటీ రిలే is giving inverse time characteristics plus definite time characteristics. Right? So inverse time characteristics up to the saturation ఏమంటాయి మనకి ఇన్వర్స్ టైం. సో ఇట్ ఈస్ అప్ టు saturation. And definite time characteristics after the saturation. So beyond saturation, we are having the definite minimum time characteristics. Definite minimum time characteristics. So up to saturation వచ్చి సో గ్రాఫ్ అనేది ఎలా ఉంటుందో మీకు ఇలా ఇన్వర్స్ గ్రాఫ్ విత్ రెస్పెక్ట్ టు టైం, రైట్. ఇక్కడేమో సో హియర్ సో మీరు అంటే ఫాల్ట్ కరెంట్ ఇలా చెక్ చేసుకుంటే సో ఇవి వచ్చి ఏమో ఆపరేటింగ్ టైం. సో దిస్ ఇస్ ద ఇన్వర్స్ క్యారెక్టరిస్టిక్స్. అదే ఇక్కడ మీరు ఫాల్ట్ కరెంట్ తీసుకున్నారు అనుకోండి డెఫినెట్ టైంలో ఏమవుతుంది మీకు ఎగ్జాక్ట్గా ఒక వాల్యూ అనేది మెయింటైన్ అయిపోతుంది, ఒక టైం. దిస్ ఇస్ ద ఆపరేటింగ్ టైం. సో ఈ రెండింటిని కంబైన్ చేస్తే వచ్చే క్యారెక్టరిస్టిక్ ఐడిఎంటీ క్యారెక్టరిస్టిక్స్. సో దట్ మీకు డెఫినెట్ మినిమం టైం అనేది ఎప్పుడు మెయింటైన్ అవుతుందంటే ఇన్ ద సాచురేషన్, దట్ ఈస్ ఆఫ్టర్ ద సాచురేషన్. బిఫోర్ దట్ వీ డోంట్ గెట్ దట్. సో దట్ దిస్ ఈస్ బికాస్ ఆఫ్ ద saturation of the magnetic circuit. Very good, Raghu, very good. So Anita and Miryala, Ashwini, and please check it. It is because of the core saturation. So most of the students are giving the perfect answers. Right. So I'm going for the next question. Students. Please check it. Right. In an electromagnetic relay, the relation between the current I in the exciting coil, the position of armature X and the flux linkages psi is given by the equation I is equivalent to 2 psi q plus 3 psi into 1 minus x plus x square. The position of armature X to have magnetic force equal to 0. Can you try it? So try to solve this question. ట్రై చేయండి అమ్మా. వాట్ ఇస్ ద ఆన్సర్? ట్రై చేయాలి ఒకసారి. వన్ ఆఫ్ ద ఈజియెస్ట్ క్వశ్చన్ మనకు ఉండేది. ట్రై చేయండి. సో దే హ్యావ్ గివన్ కరెంట్ ఈక్వేషన్ ఇచ్చారు, విత్ రెస్పెక్ట్ టు ఫ్లక్స్లో ఇచ్చారమ్మా. నెక్స్ట్ డిస్టెన్స్ కూడా ఇచ్చారు ఎక్స్, రైట్. దట్ ఈస్ ఫ్లక్స్ లింకేజ్లు ఇచ్చారు. సో వాట్ ఈస్ ద పొజిషన్ ఆఫ్ ఎక్స్, ఆ డిస్టెన్స్ ఎక్స్ ఎంత ఉంటే ఫోర్స్ 0 అవుతుందని అడుగుతారు వాళ్ళు. Right, students. So I will try it. Please check it. So Jyoti given it is option D. Very good. One person is given the answer here. Please check it, students. So what is the current equation we are having? 2 psi cube. The current equation we are having is this one. Tell me, students, how to calculate the total energy. The total energy present in the electromagnetic coil, it will be integration of 0 to psi I with respect to d psi. So that integrate this equation with respect to psi. Tell me what you are going to have here. So this will be 2 psi power 4. So రెండు ఒకేలాగా వస్తుంది ఇక్కడ. సో psi చూడండి మా 2 psi power 4 divided by 4 plus 3 psi square divided by 2 into 1 minus x plus x square. ఇదేమ్మా ఎనర్జీ ఈక్వేషన్. After calculating the energy equation, calculate the force. What is the force? So differentiate this equation with respect to energy with respect to x. So what is that force? The force developed is equivalent to differentiation of energy with respect to x and equate it to 0. Why? Because they are asking the force should be equivalent to 0. Differentiation with respect to x, the first term will be 0. So in the second term, what is that we are having? So 3 psi square by 2 is constant. So this will be equivalent to 3 psi square by 2 is constant. Differentiation of 1 will be 0 and x will be 1 and plus 2x and equate it to 0. So that you can send this portion to that side. That will be 2x minus 1 is equivalent to 0 and 2x is equivalent to 1 and x is equivalent to 1 by 2, which is nothing but 0.5. That is the answer. Right, students? So see the equations. So how to find? So E is equivalent to, right, we are having a proof for that one, the derivations of the equations. So just go through the equations, we can get all these things. So just application of the formulas, whatever you have learned already. So just try to apply that one. Clear, students? Very good. Right. Right. So I will go for the next question. I will go for the next question. Just check it. Yeah. Consider the following statements. Which of these statements are correct? Reactance relays are preferred for ground fault relaying. Just already we have discussed about that one. Impedance relays are most suitable for protecting long transmission lines. More relays are best suited for long transmission lines. Reactance relays are widely used for protection of medium transmission lines. So among these, which of the following are correct? Which of the following statements are correct? Yes, yes. Right. Bhushan, very good. Ashwini, very good. Right. Reactance relays are preferred for ground fault relaying. What is the answer? Option B. Yes, very good. Aspirant, very fast. Right. Bhushan, Uma, Jyoti, very good. You are very fast. Yeah, we'll do that. We'll do that. Patel, we'll do that. If whenever we got that question, we'll take that. Or otherwise, in the next session, we'll plan that. If you are having the questions like that, so we'll plan that. Very good, very good. 1 and 3. Everybody is giving option B. So that default, so that reactance relays are preferred for ground fault relaying. Yes, the statement is correct. Impedance relays are more suitable for protecting long transmission lines. No, they are protecting for medium lines. More relays are best suited for long transmission lines. Yes, reactance relays are widely used for protection of medium transmission lines. No, so that 1 and 3 are correct. 1 and 3 are correct. Clear, students? Right. So everybody has given the answer for this question. So you are very confident about the distance relays, right? And I am going for the next question here. In induction type directional overcurrent relays, the driving torque is due to interaction of magnetic fields derived from. In case of induction type directional overcurrent relay, the driving torque is due to the interaction of magnetic fields derived from. Right. So we are having directional unit as well as non-directional unit in case of directional relay. So that they are asking the driving torque is due to what? The driving torque is due to what? Yeah, Patel, we have discussed already about that one. So we have, so మనం already చెప్పాం కదమ్మా, in case of ఇంపిడెన్స్ రిలేస్ ఆర్క్ రెసిస్టెన్స్ మీద డిపెండ్ అవ్వడం వల్ల సో వాటి బిహేవియర్ ఆర్కింగ్ ఫాల్ట్స్లో చేంజ్ అయిపోతుంది. అర్థమవుతుందా? సో ఫాల్ట్ ఉన్నా లేనట్టుగా, అర్థమవుతుందా? సో ఫాల్ట్ లేకున్నా ఉన్నట్టుగా కన్సిడర్ చేసే సిచ్యువేషన్స్ ఉంటాయి. అర్థమవుతుందా? సో అందువల్ల ఆ మాల్ ఆపరేషన్ అవాయిడ్ చేయడానికి మనం ఏం చేస్తామంటే ఒక రిలే డిజైన్ చేస్తాం. సో ఆ రిలే రెసిస్టెన్స్ మీద డిపెండ్ అవ్వకుండా ఉండడానికి. అర్థమవుతుందా? అదే రియాక్టెన్స్ రిలే. రైట్. Very good. Everybody given option B. Both voltage and current in the relay windings. No. So you are in the wrong track. Aishwarya given the perfect answer. So it is because of directional element and non-directional element. Right? It is because of directional element and non-directional element. It is not because of voltage and current in the relay windings. No. So it is because of the interaction of directional element and the non-directional element. Right. So next question, students. Mal operation of differential protection of transformers due to magnetizing inrush current is prevented by. Mal operation of differential protection of transformers due to magnetizing inrush current is prevented by. So question, Patel. Right. So students who are having more doubts, I have already given my mail. I am again giving. Power systems dot Prasad 2010 at Gmail. Power systems dot Prasad 2010 at gmail.com. So Patel, so you can chat in mail, so we can discuss more about that reactance relays and impedance relays and the more relays. Right, students? Here they have given option C. Very good. It is bypassing the inrush current from the operating coil. Yes, very good. So if you want to avoid the mal operation, right, so we need to bypass that inrush current in the operating coil of the relay. You have to bypass the inrush current of the relay, right? So through the operating coil of the relay. Clear, students? Right. Next question. Protection scheme used to detection of loss of excitation of a very large generating unit feeding power into a grid implies. So it's a previous gate question, students. It's a previous gate question. So please go through that question. Please go through that question. Protection scheme used to detect the loss of excitation of the very large generating unit. Loss of excitation of very large generating unit. What is the answer? What is the answer? So under voltage relay, offset more relay, under frequency relay and percentage differential relay. Under voltage relays or offset more relays or under frequency relays or percentage differential relays. Tell me what is the answer? Yes, very good. Offset more relay. Yes, everybody is giving the answer. So wife knife, please check it. It is offset more relay. Offset more relay is the relay used for protection scheme, used for the detection of excitation, that is loss of excitation of very large generating unit. Very good, Sri, Upendra, everybody. Yes, very good, very good, very good. Mahesh P. Right. Right, students. Right. So now we'll go for the next question. ఇక్కడ చూడండి అమ్మా, the fault clearing process takes place in the following order in a circuit breaker. What is the fault? Fault. Yes, 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 very good. Very good. The fault clearing process takes place in the following order in a circuit breaker. So relay contacts close, CB contacts separate and arc extinguishes. Relay contacts close, the battery supplies the current to the trip coil, CB contacts separate and arc extinguished. And option C, relay contacts closes, the trip circuit of circuit breaker closes, the trip coil of circuit breaker will be energized, contacts will separate and arc will be extinguished. None of the above. So please note. Yes, yes, yes. We can discuss Patel, Manusha, right. So it's option C or option B. So Bandar Rajesh given it is option B, Anita given it is option C, Shravan Kumar C, right. Right. It is option B. Vikram, it is option B. Chudandamma. The fault clearing process. What is the fault clearing process? So first of all, the relay contacts will close. Relay contacts will close. Yes. Okay. Next one is CB contacts separate. No, not directly. The battery supplies the current to the trip coil. No, the trip circuit of circuit breaker closes. So that first one is relay contacts will be closing. Next one is the trip circuit of circuit breaker will be closing. Next one is trip coil of circuit breaker is energized. Very good, right? Next one, contacts will separate and arc will be extinguished. So this is the process we are having. Is it clear? So relay contacts will be closing and trip circuit of circuit breaker closes, trip coil of circuit breaker will be energized and contacts will be separated and finally arc will be extinguished. This is the sequence, right? So this is the sequence we are having. Clear? So when we read the statements clearly, you can give the answer very easily. Right, students? The next question. The interrupting time of a circuit breaker is the period between the instant of. What is the interrupting time of circuit breaker? Interrupting time of the circuit breaker. If you see, students, just I will come back to this question. So first of all, we'll see the operating time. What is the operating time of the circuit breaker, not the total operating time. The total operating time, suppose if we are taking like a pulse, if this is the pulse we are having. So here we got the fault. This is the instant of fault. From instant of fault, we are having the relay operating time. and later we are having CB operating time. CB operating time. And finally relay reset time. Relay reset time. This is the total operating time of the whenever the fault occurs. So that whenever the fault occurs, so the instant of the fault, so the relay operation will end. When it will be end, relay is giving the trip signal to the circuit breaker. So that here trip signal is sent to circuit breaker. Trip signal sent to CB. Sent to CB. From there CB operating time. So CB operating time will be divided into two parts. One is CB opening time and arcing time. CB opening time and arcing time. So from here we can take this as two parts. One is CB opening time and arcing time. CB operating time will start. So what is the CB opening time? CB opening time will start whenever trip signal is received from the circuit relay, right? And from there to CB contacts are fully opened. Here it is. CB contacts are fully opened. Or we can say arc is initiated. So what is the arcing time? Arcing time will be completed when arc is fully extinguished. Arc is fully extinguished. Or we can say fault is cleared. So that what is the fault clearing time? The fault clearing time will be from the instant of fault occurred. We can write as fault occurred. From the instant of fault occurred to the instant of fault is cleared. That is the fault clearing time, right? So from here to here we can say it is the fault clearing time. And here relay reset time. So it is at this position relay back to its original point. Its original position. Clear, students? So that it is the instant of fault occurred and it is a trip signal sent to the circuit breaker or trip signal received by the relay to the circuit breaker, and CB contacts are fully opened or arc is initiated, and here it is arc is fully extinguished or fault is cleared and relay back to its original position, right? So these are the operating times, right? So now you can say, so what is CB opening time? What is the arcing time? What is the CB operating time? What is the relay operating time? What is the overall operating time, or what is the fault clearing time? Right? Yes, CB opening time is always greater than that of, very good. Yes. Tell me, students, what they are asking? The interrupting time of circuit breaker is the period between the instant. What is the interrupting time? It is initiation of short circuit and the arc extinction on an opening operation. Right. Next one. Energizing of the trip circuit and the arc extinction on an opening operation. Initiation of short circuit and the parting of primary arc contacts. Energizing of trip circuit and the parting of primary arc contacts. Tell me. So what is this one? Right. So what is this one? So energizing of the trip circuit and the arc extension of an opening operation. Energizing of the trip circuit and energizing of the trip circuit and the arc extension on an opening operation. That is the interrupting time. interrupting time. Simply you can call it as, what is that one? Just where you are getting the energizing of the trip circuit. So here we are getting the energizing of the trip circuit and arc will be fully extinguished here. Arc will be fully extinguished. That is the CB operating time, that is the interrupting time of the relay, interrupting time of the circuit breaker, right? Very good, very good, very good. Right, students, right? I am going for the next question. I think it is clear for you, the operating time, right? Just see here, so it is one of the previous questions. Just go through this question and try to solve this one. In a 220 kV system, the inductance and capacitance up to the circuit breaker location are 25 millihenry and 0.025 microfarads respectively. The value of resistor required to be connected across the breaker contacts, which will give you no transient oscillations. So I am expecting the answer from everybody for this question because it is one of the famous question. So what is the value of resistor required? To be connected across the breaker contacts, which will give no transient oscillations. What is the answer? Option C, aspirant given. Very fast, very good, Ashwini. Very good. Right. So what is the answer? Entama resistance value anta pettukovali manam ikkada 0.5 into root of L by C. 0.5 into root of L by C. Antena? So ఇది 0.5 into root of L ఎంత ఇచ్చారమ్మా 25 మిల్లీ. 25 మిల్లీ అంటే రాస్తామా, మిల్లీని ఎలా రాయొచ్చు 0.024 రాసేయచ్చు కదా. అండ్ ఇక్కడ మైక్రోఫారడ్, సో 0.025 మైక్రోఫారడ్. సో 0.025 క్యాన్సిల్ అయిపోతే మనకి ఏమొస్తుంది ఇక్కడ 0.5 అండర్ రూట్ ఆఫ్ 10 power plus 6. సో డినామినేటర్లో 10 power minus 6 పైకి వెళ్తే 10 power plus 6 అండ్ 10 power 3 0.5 into 10 power 3 ఎంత అవుతుంది ఇది 500 ohms. అంతేనా? సో వెరీ సింపుల్ క్వశ్చన్. వెరీ గుడ్. రైట్ స్టూడెంట్స్, రైట్. సో ఐఎమ్ గోయింగ్ ఫర్ ద నెక్స్ట్ క్వశ్చన్ నౌ. చూడండి ఒకసారి. ఫ్రమ్ ఎకనామిక్ లోడ్ డిస్పాచ్. సో దిస్ టైప్ ఆఫ్ క్వశ్చన్, ఇటువంటి క్వశ్చన్స్ మనకి ఎప్పటి నుంచో వస్తున్నాయమ్మా ఎకనామిక్ లోడ్ డిస్పాచ్లో. మీరు ఎకనామిక్ లోడ్ డిస్పాచ్ని నెగ్లెక్ట్ చేయొద్దండి, కొద్దిగా క్లియర్గా చూసుకుంటే. సో స్మాల్ లెవెల్ నుంచి హై లెవెల్ వరకు చూసుకున్నామంటే కూడా సో ఛాన్స్ ఆఫ్ అకరెన్స్ ఆఫ్ అట్లీస్ట్ వన్ క్వశ్చన్ అన్న మనకి ఈజీగా రావడానికి ఛాన్స్ ఉంటుంది. ద ఇంక్రిమెంటల్ ఫ్యూయల్ కాస్ట్ ఫర్ 2 generating units are given by IC1 is equivalent to 25 plus 0.2 Pg1 and IC2 is equivalent to 32 plus 0.2 Pg2. Right. Where Pg1 and Pg2 are real power generated by the units, the economic allocation for a total load of 250 megawatt neglecting the transmission line loss is given by. Line loss is given by. What is the answer for this question? Entama? So option B వచ్చిందా నీకు 109.75 and 140.25 వచ్చిందా? ఐశ్వర్య యు గాట్ ఆప్షన్ ఏ. క్వశ్చనే చాలా ఈజీ, వైఫ్ లైఫ్ క్వశ్చనే చాలా ఈజీగా ఉంటుంది, మీరు ఒకసారి సాల్వ్ చేస్తే సరిపోతుంది అంతే. చూడండి అమ్మా, ఎకనామిక్ ఆపరేషన్కి ఏముండాలమ్మా ఇంక్రిమెంటల్ ఫ్యూయల్ కాస్ట్ సేమ్గా ఉండాలి. సో ఇంక్రిమెంటల్ ఫ్యూయల్ కాస్ట్ని సేమ్ చేయండి. క్వశ్చన్ చాలా సింపులే. రైట్, ఒకసారి చూడండి అమ్మా. సో IC1 షుడ్ బి ఈక్వల్ టు IC2 అవ్వాలి, అంతేనా? సో 25 ప్లస్ 0.2 Pg1 మస్ట్ బి ఈక్వల్ టు 32 ప్లస్ 0.2 Pg2. ఇటు సైడ్ తీసుకొచ్చానమ్మా. సో 0.2 అవుట్ సైడ్ ఇస్తే Pg1 మైనస్ Pg2 ఈజ్ ఈక్వల్ టు ఎంత 32 మైనస్ 25 ఇట్ విల్ బి 7. అప్పుడు Pg1 మైనస్ Pg2 ఎంతమ్మా? Pg1 మైనస్ Pg2 7/0.2. 1/0.2 అంటే 5 కదా. సో 7 5 are 35, అంతేనా? సో దట్ Pg1 మైనస్ Pg2 ఎంత వచ్చింది 35. అండ్ Pg1 ప్లస్ Pg2 టోటల్ లోడ్ ఎంత ఇచ్చారు 250. Pg1 ప్లస్ Pg2 ఎంత 250. అంతేనా? సో యాడ్ చేస్తే PG2 క్యాన్సిల్ అయిపోతుంది కదా. సో 2 టైమ్స్ ఆఫ్ PG1, 2 టైమ్స్ ఆఫ్ PG1 ఎంత వస్తుందమ్మా మనకి? 285, అంతేనా? 250, 285. PG1 ఎంత వస్తుందమ్మా? హాఫ్ ఆఫ్ దిస్ వన్, 140.25, 140.25. ప్లీజ్ చెక్ చేయండి అమ్మా. PG1 వచ్చి 140 వస్తుంది. సో రిమైనింగ్ వచ్చి PG2. సో PG2 ఎంత రావాలి? 109.75. చూడండి అమ్మా, ఆప్షన్ ఏ వస్తుంది. యా టైం కన్జ్యూమ్స్, అందుకే ఒక క్వశ్చన్ వస్తుంది మనకి, అంతమంది ఎక్కువ రాదు. ఒక క్వశ్చన్ వస్తుంది. 100 క్వశ్చన్స్లో మనం పవర్ సిస్టమ్స్ నుంచి 20 క్వశ్చన్స్ అంటే ఎకనామిక్ లోడ్ డిస్పాచ్ నుంచి ఒకే క్వశ్చన్ వస్తుంది. అర్థమవుతుందా? అది రిలేటెడ్ వాళ్ళు ఇచ్చిన డేటా మీద డిపెండ్ అవుతుంది అనమాట. సో దానిలో షార్ట్ కట్స్ కావాలంటే మనకి వాళ్ళు ఇచ్చిన డేటా కరెక్ట్గా ప్లాన్ చేస్తే అప్పుడు మనం చూసుకోవచ్చు. సో ఇటువంటి క్వశ్చన్స్కి క్వశ్చన్ సాల్వ్ చేయడమే తప్ప ఇంకో ఆప్షన్ లేదు. అర్థమవుతుందా? రైట్. అది ఇక్కడ డిజైన్ చేసి IC1ని IC2ని డిజైన్ చేసేదాన్ని బట్టి మనం షార్ట్ కట్స్ చెప్పచ్చు. రైట్. నెక్స్ట్ క్వశ్చన్ చూడండి అమ్మా. 142 వచ్చిందా? 142. ఓకే. సో నియరెస్ట్ అదొకటే పాసిబుల్ కదా, ఇంకోటి పాసిబుల్ అవ్వలేదు. 142 వచ్చిందా? ఓకే. రైట్. 142. సో ఆడ టైపింగ్ 142 ఉండాలి అయితే, అంతేలేండి, కరెక్టే. రైట్. ఈ క్వశ్చన్కి ఆన్సర్ చెప్పండి అమ్మా. ఎస్. అంతే కరెక్ట్, టైపింగ్ మిస్టేక్. ఏ 3-phase 66 kV ఆయిల్ సర్క్యూట్ బ్రేకర్ ఈజ్ రేటెడ్ 1200 amperes, 8000 MVA, 3 seconds. ద సిమెట్రికల్ బ్రేకింగ్ కరెంట్ ఎంతమ్మా? సిమెట్రికల్ బ్రేకింగ్ కరెంట్ చెప్పాలి. A 3-phase 66 kilovolts oil circuit breaker is rated 1200 amperes, 8000 MVA, 3 seconds. The symmetrical breaking current is. What is the symmetrical breaking current formula? Symmetrical breaking current or breaking capacity. Is nothing but √3 times of V line into I line. √3 times of V line into I line, where I line is the rated line to line voltage and IL is the line current which is flowing there. From that one we can calculate the I line, so which is nothing but symmetrical breaking capacity. It is given as 8000 MVA. It is 8000 into 10 power 6, 8000 into 10 power 6 divided by √3 into V line. V line ఎంత ఇచ్చారమ్మా? 66 into 10 power 3. ఈ ఈక్వేషన్ మీరు సాల్వ్ చేయాలమ్మా. మీరు సాల్వ్ చేస్తే నియర్గా 69 పాయింట్ సంథింగ్ వస్తుంది. అరవింద్ రెడ్డి ఆల్రెడీ గివెన్, ఐశ్వర్య కూడా ఇచ్చేశారు. రైట్. సో అప్రాక్సిమేట్లీగా 69 పాయింట్ సంథింగ్ ఎంత వస్తుంది. మీరు ఈక్వేషన్ సాల్వ్ చేయాలి ఖచ్చితంగా, తప్పదు, ఎందుకంటే ఇది వన్ ఆఫ్ ద ప్రీవియస్ క్వశ్చన్. రైట్. సో నియర్లీ అప్రాక్సిమేట్లీ 70 kilo amperes వస్తుంది. అప్రాక్సిమేట్గా 70 kilo amperes వస్తుంది. రైట్ స్టూడెంట్స్? ఎస్, వెరీ గుడ్. 69.8. రైట్. మన క్యాలిక్యులేటర్ ఉండదు కాబట్టి కొద్దిగా టైం తీసుకోవాలి ఇటువంటి క్వశ్చన్స్కి, తప్పదు, ఎందుకంటే కొన్ని టైమ్స్ అలా డిజైన్ చేస్తున్నారు క్వశ్చన్స్. అర్థమవుతుందా? క్యాలిక్యులేషన్ పార్ట్ చెక్ చేసుకోకుండా కొన్ని టైమ్స్ ఇస్తున్నారు. సో ఇటువంటి క్వశ్చన్స్ మనకు కొద్దిగా టైం ఎక్కువ కన్జ్యూమ్ చేసుకుంటాయి. అర్థమవుతుందా? సో ఆ క్యాలిక్యులేషన్ పార్ట్ మనం కొన్ని ఎక్కువ, అందుకని మీకు ఎందుకు చెప్తున్నా అంటే ఎక్కువ క్వశ్చన్స్ మీరు ప్రాక్టీస్ చేయాలి. ఎక్కువ క్వశ్చన్ మీరు ప్రాక్టీస్ చేసేటప్పుడు మీకు అర్థమవుతుంది, క్యాలిక్యులేటర్ కూడా యూస్ చేయకుండా కొన్ని డిఫికల్ట్ క్వశ్చన్స్ ఇస్తారు అని మీకు అర్థమవుతుంది అనమాట. అర్థమవుతుందా? అది మీనింగ్. వెరీ గుడ్ అమలా. రైట్ స్టూడెంట్స్. నెక్స్ట్ క్వశ్చన్. విచ్ ఆఫ్ ద ఫాలోయింగ్ సర్క్యూట్ బ్రేకర్ హ్యాస్ హైయెస్ట్ రిలయబిలిటీ అండ్ minimum maintenance? Which circuit breaker is having very high reliability and minimum maintenance? Which circuit breaker is having high reliability and minimum maintenance? ఏ సర్క్యూట్ బ్రేకర్ అమ్మా? ఎస్, ఓకే, శ్రీ, ఓకే, వెరీ గుడ్. సో which of the following circuit breaker is having the highest reliability and minimum maintenance? Option A, it is circuit breaker with SF6 gas. Very good, it is SF6 So Bhushan, it's not vacuum, it is SF6. SF6 is perfect, right? So it is having the highest reliability, right? And it needs minimum maintenance compared to that of vacuum also. Clear? So students, these are the questions we are having for today's session. So we have taken some questions in the relays part, we have taken some questions related to circuit breakers, and we have taken at least one question for the economic load dispatch. So in the next session we will change, we will take more questions on economic load dispatch, some questions related to circuit breakers as well, right? So and some questions related to the relays also, right students? So these are the questions we are having. So thank you for responding everybody, right? I think the session is very clear. So మొత్తం అర్థమైంది అనుకుంటున్నాను, right students? Thank you.